Welcome to True Projects. In this video, we are going to explain about the project titled Investigating the Emotional Response to COVID-19 on Twitter, a topic modeling and emotion classification approach. Introduction. This project's primary goal is to gain insight into how people are sharing their feelings and thoughts related to COVID-19 on Twitter. Twitter is a platform where users openly express themselves, making it an ideal source for understanding public sentiments during significant events. The COVID-19 pandemic has had a massive impact globally. Knowing how people feel and what concerns them is essential for responding effectively to the crisis. Twitter serves as a valuable resource because it provides real-time updates on public sentiment. This understanding is crucial for making informed decisions during challenging times. Analyzing the vast amount of data on Twitter can be overwhelming. This project addresses this challenge by using techniques like topic modeling to identify common subjects of discussion and emotion classification to determine the prevailing sentiments. These analyses help in making sense of the Twitter chatter, ultimately contributing to a better understanding of how the public is responding emotionally to the COVID-19 pandemic. Objective. The main objective of the project is to examine how people express their feelings and thoughts, especially related to COVID-19, through their social media posts, which in this case are tweets on Twitter. By doing so, we aim to gain insights into public sentiments during this crucial time. To achieve our objective, we utilize a variety of algorithms ranging from traditional ones like Navy-based to advanced techniques such as BERT, Roberta, GRU, LSTM, CNN, and an ensemble model. These algorithms serve as tools to extract valuable information from the text data. They enable us to perform tasks like simple sentiment analysis with Navy-based and more complex emotional analysis using deep learning methods like BERT and LSTM. These algorithms play a vital role in categorizing sentiments, spotting trends, and understanding the emotions expressed in tweets related to COVID-19. This analysis offers valuable insights that can guide decision makers, policy makers, and researchers in making informed choices to address public needs effectively during the pandemic. It helps ensure that responses and strategies are well informed and tailored to the sentiments and concerns of the general population. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. This initial step involves bringing in software libraries and tools necessary for the project. These packages provide functions and methods to perform various data analysis and machine learning tasks efficiently. The common packages which we have used in this project are NumPy, Pandas, Matplotlib, Seaborn, etc. Exploring the dataset. Here, the project involves examining the dataset, which likely contains a large number of tweets related to COVID-19. This exploration phase includes checking the data structure, size, and content to understand what information is available for analysis. Data processing. After exploring the dataset, the next step is data processing. This includes tasks like cleaning up messy or incomplete data, handling missing values, and structuring the data in a way that makes it suitable for analysis. It's a critical step to ensure accurate results. Visualization using Seaborn and Matplotlib. Data visualization is essential for gaining insights from the data. Seaborn and Matplotlib are Python libraries commonly used for creating visual representations like graphs and charts. They help in visually identifying trends, patterns, and relationships within the data. Data cleaning. Data cleaning is a specific part of data processing where any inconsistencies, errors, or outliers in the data are addressed and corrected. It ensures that the data is reliable and accurate for analysis. Tokenization based on BERT for TL and Keras for deep learning. Tokenization is the process of breaking down text into individual units or tokens, which can be words or subwords. In this project, two different tokenization methods are used. BERT for TL, suggests that the use of tokenization techniques specific to BERT, bidirectional encoder representations from transformers, for transfer learning. Keras for deep learning implies using Keras, a popular deep learning library for tokenizing text data. Tokenization is a crucial step before text-based analysis. Splitting the data to train and test. In machine learning and deep learning, it's common practice to split the dataset into two parts, training data and testing data. The training data is used to train the models, while the testing data is used to evaluate the performance. This decision ensures that the model's accuracy and generalization can be assessed effectively. Building the model, in which we have used different algorithms. The first algorithm which we have used is Navy Bayes. Navy Bayes is a classic machine learning algorithm used for text classification tasks, including sentiment analysis. It works by calculating the probability of a particular sentiment or class given the words in a text. Despite its simplicity, it can provide reasonable results for sentiment analysis tasks. BERT, bidirectional encoder representations from transformers. BERT is a state-of-the-art natural language processing (NLP) model. It's a deep learning model that understands the context and relationships between words in a sentence, making it highly effective for tasks like sentiment analysis. BERT-based models have achieved remarkable performance in various NLP applications. Robota is another advanced NLP model, an extension of BERT, designed to further improve performance. It fine-tuned BERT by training on more data and for longer periods, resulting in even better language understanding capabilities. GRU, Gated Recurrent Unit. GRU is a type of recurrent neural network (RNN) used for sequence data analysis. It's capable of capturing dependencies between words in a text and is often used for sentiment analysis and text classification tasks. LSTM, long short-term memory. LSTM is another type of RNN known for handling long-range dependencies in sequences. It's highly effective for NLP tasks like sentiment analysis, as it can capture context and relationships between words over longer distances. CNN, Convolutional Neural Network. CNNs are typically associated with image processing, but they can also be used for text analysis. In this context, they are used to capture local patterns and features in text data, making them effective for tasks like sentiment analysis. Ensemble model. An ensemble model combines the predictions from multiple models to improve overall accuracy and robustness. In this project, it likely involves integrating the outputs of various models, example Navy Bayes, BERT, LSTM, etc., to make a collective prediction. Ensemble models often outperform individual models by reducing biases and errors. Training the model. This phase involves teaching the machine learning or deep learning model how to understand and predict emotional responses in tweets. The model is exposed to a large data set of labeled examples where it learns to recognize patterns and relationships between words and emotions. This training process is essential for the model to make accurate predictions. Building the model with LSTM gives better accuracy. LSTM, long short-term memory, is a type of recurrent neural network (RNN) known for its ability to capture context and dependencies in sequences of data such as text. The statement suggests that among the models used in the project, LSTM performs the best in terms of accuracy when it comes to predicting emotional responses in tweets. Flask framework with SQLite for sign-up and sign-in. Flask is a web framework for building web applications in Python. In this context, Flask is used to create a user-friendly web application. SQLite is a lightweight database system that is often used for small to medium-sized web applications. It is employed here to manage user registration sign-up and login sign-in. User gives input. Users of the application provide input, likely in the form of text related to COVID-19 or their emotional state. This input is the basis for predicting their emotional responses. The given input is pre-processed for prediction. Before using the trained model to predict emotional responses, the user's input text undergoes pre-processing. This involves tasks like tokenization, cleaning, and formatting to ensure that the text is in a suitable form for analysis. Trained model is used for prediction. The trained model, which has learned from the earlier training phase, is employed to predict the emotional response based on the pre-processed user input. The model has already learned patterns from the training data, and it applies this knowledge to the user's input to make a prediction. Final outcome is displayed through front end. The predicted emotional response is then displayed to the user through the web application's front end. This provides the user with valuable insights into how their input text is perceived emotionally, enhancing their understanding of the sentiment behind their words. Execution. To execute this project, first we need to open the code folder which contains the project source code file. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file, which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is a database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the correct directory to the code folder's path. Compile the app.py file using the command python space app.py. I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flash framework will host the application locally at the default address, which is 127.0.0.1 and port, which is 5000. Now copy this local link. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome. Now hit enter. The home page of the project is displayed in the browser. This is the front end built using Flash framework. Now click on sign up button. If we are a new user, we need to register first, but I have already registered, so click on sign in. This is the login form. Here we need to enter the username and the password which we have created. So I'm entering the username and the password and click on sign in. This is the home page of the project. Here we need to enter a message in the text box. After entering the message, we will predict the sentiment of the tweet. So here I'm entering the message. This is the message which I have entered. Now click on predict. So here we can see we got the results for the tweet. So the sentiment of the tweet is positive. So let us enter one more message and check the sentiment of the tweet. So here this is the message which I have entered. Now click on predict. So here we can see we got the results for the tweet. The sentiment of the tweet is extremely negative. Now let us enter one more message and check the sentiment of the tweet. So I'm entering one more message. Here, this is the message which I have entered. Now click on predict. So here we can see the sentiment of the tweet is neutral. So now let us enter some more messages and check the sentiment. So I'm entering one more message. This is the message which I have entered. Now click on predict. Here we can see the sentiment of the tweet is negative. Now let us upload one more message. So I'm entering one more message. This is the message which I have entered. Now click on predict. So here we can see results for the tweet is the sentiment of the tweet is positive. So in this way, by entering the tweet, we can predict the sentiment of the tweet, whether it is positive, negative, neutral or extremely negative or positive. And the conclusion of the project is the project's first achievement is gaining a profound insight into how people on Twitter share their emotions and thoughts during the COVID-19 pandemic. By examining a massive data set, the project covered a wide range of aspects, including sentiment, how people felt, and topics, what they discussed. This comprehensive analysis provided a holistic view of how the public responded emotionally to the pandemic. Through rigorous testing of various algorithms, the project found that LSTM, long short-term memory, a type of recurrent neural network, excelled in accurately understanding emotions expressed in tweets. This discovery underscores the value of employing advanced techniques like deep learning for emotion analysis. LSTM's ability to capture context and relationships between words contributed to its effectiveness. To make the project's finding accessible and practical, an easy-to-use web application was developed using Flask. This app utilizes the LSTM model to predict emotions based on user input. It serves as a valuable tool not only for researchers but also for the general public, helping them navigate and understand emotional expression, especially in times of crisis such as COVID-19 pandemic. This application bridges the gap between advanced data analysis and real-world usability, providing actionable insights.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.